Hello everyone, this is lecture 67 of Principles of Electric Circuits. Let's discuss two new concepts, that is reactive power and apparent power. We've never contacted these two concepts. In this lecture, we will talk about their definitions and why do we introduce these two concepts. We introduce the reactive power first. We have deduced the instantaneous power of the one-pole network in lecture 65. It's the first expression. That is to say, instantaneous power can be divided into the constant part and the reversible part with double frequency. The waveform is like this. Then we derive the second expression. That is to say, instantaneous power can be expressed as the reversible and reversible parts. The waveform is like this. Based on the first expression, we find its integral and get that its term is the average power of all the active power. In this lecture, the maximum of the reversible part in the second expression is defined as a reactive power Q. We will explain the reason of this definition later. Here we only need to emphasize that the unit of Q is VAR. It is the acronyms of the voltage ampere reactive. Similar to active power, the reactive power is also conserved in the whole circuit. That is to say, the sum of the reactive power supplied by all elements is zero. Next, we will discuss the reactive power absorbed by the resistors, capacitors, and inductors. For the resistors, the factor angle is 0 degree. So, that is to say, the resistors don't absorb reactive power. For inductors, the voltage leads the current 90 degrees. That is, the power factor angle is 90 degrees. It means that inductors always absorb reactive power. For capacitors, the current leads the voltage 90 degrees. It means that power factor angle is minus 90 degrees. And capacitors always absorb negative reactive powers, or conversely, capacitors always supply reactive power. It can also be understood as capacitors are always reactive power source in SS circuits. Next, we discuss the physical meaning of the reactive power. Look, it is the second expression about the instantaneous power we derived in lecture 65. Here we think the initial phase angle of the voltage is 0 and the current lags angle phi. For inductors, phi equals 90 degrees. So this term is 0. The instantaneous power of this inductor is. Through the discussion in previous slides, we know that the reactive power absorbed by the inductor is U times I. So it's equal to, for capacitors, phi equals minus 90 degrees. Similarly, this item is 0. Thus, through the discussion in previous slides, we know that the reactive power absorbed by the capacitor is. We have deduced the expressions of the instantaneous power absorbed by the inductor and the capacitor. We know that the power is the differential of the energy. You see, for the inductor and the capacitor, power is a function of time. Reactive power absorbed by the inductor and the capacitor is a maximum value of the function of time. It means that the reactive power presents the maximum rate of energy change on the capacitor and the inductor. That is the physical meaning of the reactive power.